Hello, my friends of Qatari Labs. My name is Saul Montoya. Welcome to this webinar. In this webinar, we are going to work with the generation of maps without rain. Okay, what does it mean? That we are going to process. So this is a post-processing. We are not really this time. We are not, or we don't want to model maximums. We don't want to model minimums. We don't want to model media precipitation. We don't want to get any quantile. We want to count how many days there was without precipitation. Okay, that is a great index about the aridity, or you could take this for any water, for any land management technique and so on. Okay, so this is done, and we are going to work with Python and Rasterio. uh, Python, well, is the programming language, but Rasterio is a package that can handle rasters. In this case, the data is come from the CHIRPS dataset, and this is on NetCDF format. Okay, so and the NetCDF format is pretty I mean, can handle many layers. Okay, is heavy. Okay, and well, I don't know if I don't know much any other software. Well, I'm sure there is that can handle well the NetCDF format, but it's possible here with Python. And then from the results of this raster, well, in fact, we are going to create an array. We are going to export that array into a geospatial raster. Okay, so far I see that how many of you are here. We have 7 people here. I would like that you introduce yourself through the chat. Okay, where are you from and which is your Python level? Okay, and then we start while we start the webinar. Okay, you have received on the description of the video a folder. Okay, and the folder, okay, you have to place it here under your document folder. Okay, so here this is the folder webinar generation, and then you have, okay, you have it, you have downloaded zippet. Okay, but you have to place it here under your document, and it's imperative that you do it this way. Okay, if you are here with me, please type 1. Okay, great. Riyad, great. Riyad, David, Luis. Okay, great. Okay, Razak comes from Nigeria, hydrologist and researches at Tijan University. Nice to meet you, Razak. Who else? Please introduce yourself. Okay, and who else do not have the material? Who else do not have Anaconda installed? Let me know. Okay, okay, okay. Hamduni, this is from Tanzania. Wow. Also, okay, great. Okay, does anybody has a problem with the material and the content, and then do you have an account installed in your computer? Okay, please let me know. Okay, so we have Luis Arturo from Bolivia. Where exactly in Bolivia? La Paz. Luis Arturo. Okay, so Potosí. Wow. Askanska from India, researching in Madras. Okay, right. Okay, so let's see. Anaconda Prom, Juan Blandón, Could you introduce yourself? Okay, do me. Okay, please, could anybody share the link of the material through the chat? Okay, and the password is Hatari Labs with capital H. Okay, can anybody share on the? Okay, so here we have Anaconda Prom. Okay, Hatari Labs. Yeah, could anybody share the link of to download the material? Because actually I don't have it right now. Uh, please. Oh, I'm not very supporting. Okay, I have to look for that. And Juan is from Uruguay. He works as a. Okay. Yeah. Thank you, Riyad. Okay, so my friend Handuming, this is the link, and the password is Hatari Labs with capital H, as Kanska has said. Okay, and he's a teacher and the at the agremental engineering program. Okay. Okay. Great. Agri-environmental engineering program. Okay, great. CD documents. Okay, if we type there, we are going to see the webinar folder here. So we type the password is Hatari Labs with capital H. Okay, so the webinar. Okay, okay, and then here you type Jupyter Lab. Here you type Jupyter Lab. Great. Great, Razak. Okay, so you go here to this. Okay, you just type Hatari Labs and then you type download and it will download a zip file. It's so easy. Okay, great. So we are here. Okay, so we have a data folder here that is where the CHIRPS dataset is actually stored. Okay, if you are here with me, please type 2. If you are here with me, please type 2. Okay, we are going next. Okay, we are thinking in opening the diploma on Python for water resources again. Okay, but in this time we want to have a better insight of the if that you will be interested in having a diploma that will teach you not from the beginning because actually the introduction to Python it will be recorded, but applied Python for water resources. Okay, so if you are interested in that, please type interested, or like if you are not interested, I mean, like, well, if you are not interested, you don't type anything. I mean, actually, no commitment. Just type if you will be interested in following a 4-month uh, program of advanced Python for water resources. Okay, so let me know through the chat. It's important that your it's important your interest because this is a measure if we open the program or not. Okay, so here we are going to rename the notebook and this will be called part 1. Okay, only Handumi is interested. Okay, great, don't worry. Is Hatari Labs all together with capital H. Hatari Labs all together with capital H. Okay, so here let's see. Okay, so let's see, let's import the required packages. Okay, so I say import rasterio.mask as mask from rasterio.plot import show Okay. Import matplotlib.pyplot as plt. Import geopandas as gpd. Okay. And say import numpy as np. Import rasterio. Import volume. Okay, great. So maybe you don't have, okay, maybe you don't have, okay, maybe you don't have all of these, okay, all of these packages. So that is why we are going to first try to install it, okay? In order to install it here in Jupyter Lab, so you have to type exclamation pip install. We are going to work rasterio, geopandas, volume. Yeah, so we just run it. I'm running it with shift enter. You can run it with this. Okay, once, okay, once you have run it, please type 3. Okay, you have to run this just only once. Okay, because, okay, so, well, it was already installed. Okay, and once it has installed, just comment and run it again because you are not going to need it anymore. And then with that, we are sure that we can run this cell. If you are here with me, please type 3. Who else? Who else is here with me? Juan, David, Darío, and the 5 others. Okay. Okay, great, great, great. Okay, so dataset ds is equal to rasterio dot open, okay, of data, and then we open the CHIRPS NC, okay, and well, it can open that, okay, so it's actually pretty able to open an NetCDF file, okay, so we can get some information about the bounds, okay. There is a problem here that, for example, how many bands it has. It has 365, and which is the CRS, and the problem is that there is no CRS. I mean, the NetCDF do not come with a CRS compatible, but we assume that is WGS84. Okay, great. If you are here with me, please type 4. Okay, but you can, I mean, when those things happens to you, you can go to the documentation of the datasets and they will provide which is the CRS that they're working with. Okay, this is the academic way. Great. Who else is here with me? Just to remember that I am running the cells with Shift Enter instead of running from here. Okay. Mhm. Uh, what is RIAD? What is the question? The, okay. Bounds is the limits, is the minimum x, I mean the minimum longitude, maximum longitude, no, the minimum longitude, the minimum latitude, the maximum longitude, the maximum latitude. I mean from the extension is the whole word. Okay. Okay. For example, if we want to know the x and y of a certain cell, there is a reverse. So, for example, there is the xy, where we gave the row and column, okay, and it gave us the long and lat. Okay. As Kanka said, how do you know what info in the NC file having? Well, that's a great question, but this comes from the documentation. Okay, so the documentation, the provider of the data give you that information. Okay, because there is the DS, sometimes there is DS meta. Okay, and it give you, for example, that is NetCDF, float, the width, the height, and the transform. But the affine comes here. Interesting. Okay, but however, doesn't give you which is the pixel. What does it mean every pixel value? Okay, so let's see. So we can show, yeah, we can show for example, the read for the first band. Okay, so there will be the 1st of January. We can show the okay, we can show here which is the precipitation for the 1st of January. Okay, don't worry because actually the color scale is pretty lousy because you have there is no data on the at the sea. Okay, and this no data at the sea actually will, how to say, will mess up with the scale. Okay, so that is why in this extension the scale is crappy. Okay, uh, as Kafka say, is having 365 data is means for count. It is having, yeah, yeah, it has 300. I mean, this raster has 365 layers. Okay, and each one is for each data. Okay, and CRS means the system of reference. Okay, so and it doesn't have any system of reference. Okay, great, great questions. Okay, so we can show, when we do show only the DS, because in the other case we have just plotted one layer. Okay, when we show all the DS, actually it will give us this. Okay, well, it understands the not a number. Okay, it understands the C's. Okay, and it will provide us, I think that this is the sum. Okay, this is the sum of all precipitation. Okay, or maybe it's the last one. Okay, yeah, but well, give us a better graphic. Okay, with some values. Which values we don't know. Okay, great, 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 great. If you are here with me, please type 6. Great, great, great. Okay, great. So let's continue. So world borders. Okay, so I mean, we are not going to make the days of map of days without rain for the whole world. Actually, this is not possible. Or well, it's possible, but it's not of much. Okay, what we are going to do is we are going to do read file of data. Okay, we are going to work with the world countries.shapefile. Okay, and then we are going to world borders. We are going to show the CRS of this shapefile. This is a shapefile that I have also downloaded from the web, and this is in WGS84. Okay, great. If you are here with me, please type 7. Abdullah, yes. How are you doing? Mhm. Great, great, great. Luis Arturo Lopez and Luis Felipe Simba, have you introduced yourself through the chat? Please introduce yourself because actually I don't remember you very well. One of you have introduced through the chat. I mean, please, for the other. We're a small group, so okay. So let's see. War borders dot plot. Okay, so we are going to plot our CRS is for the system of reference. It's not a function, it's an instance. Okay, so it's a property for the system of reference. Yeah, I mean, I don't know. I mean, when you use, I understand. If you use ArcGIS, actually the CRS is a meta topic because it's not required. But when you use QAS, you are always want to define your special data with the system of reference. Okay, so this is the world borders. Okay, but we want a defined country. Okay, in this case, we are going to work with Colombia. Okay, but it could be any country because if you open world borders, this is a panda data frame, a geopanda data frame. You have just to filter by the country name. Okay, so let's see. World borders country equals Colombia. So this is will be col row reset index col row. Okay, so this is just Colombia. Okay, great. And but then we can get the border. Okay, by okay. I don't know if you are very familiar with GeoPandas, but in GeoPandas you have the geometry, and the geometry is actually I mean the geometry is how say can be represented graphically. Okay, call border is equal to call row dot I log 0 dot geometry. Okay, so call border. Okay, so this is the Colombia border. It's so funny. I think that San Andres is here. So it appears here is San. Okay, so this is the geometry. Okay, so if we type the type of call border is a shapely multi polygon, is a multi-polygon of shapely. Okay, I don't know if you are very okay. Please tell me if you are familiar with geospatial Python and shapely and geopandas. Please tell me yes or please tell me no. Great. Okay, because there is a whole discussion about what is a multi-polygon, a polygon, a shapely, a geometry, and so on. Well, and this is how we treat things in Python, geospatial thing in Python. Okay, who else? Only Juan? Okay, well, don't worry. Yeah, but yeah, I mean, if you are more related with Python, with geospatial Python, you will be more related to the geometry, the multi-polygon, so on. Okay. Okay, so let's see. Let's see the. Okay, so we are going to out image. Okay, out transform. Why? Okay, we are going to clip our data set to the. We are going to clip. Okay, it's empty for you, Askanska. Askanska, could you share your screen quickly? Okay, we are going to clip. Okay, okay, we are going to clip the data frame to the color border. Okay, we can clip it. Okay, and then we are going to crop it. Okay, so we just want data there. Okay, okay, I want to see what Skanska is doing. It's Colombia. Skanska, you have to change. It's Colombia with O. Colombia. C-O-L-O. Okay, run the cell, rate, and run the cell again. Okay, rate and run the cell. Type. Okay, great. So let's continue sharing. Yeah. So so the mask that comes from Rasterio give you the mask, the cropped image, but also give you the transform. And what is the transform? The transform is an array that helps you to reference the image, okay, an array to a raster. So it's the transforming array, okay? So it will interpret anything that is on an array that is expressed on row and columns to a raster that is expressed on cells of X and Y. If you have understood this, please type 8. Uh, Juan Blandon says that GeoPandas is the easiest way to treat your referenced vectorial data in Python. Yes, maybe for vector data is the easiest one, but when you deep into doing some complex queries, then you are going to deal with mostly raster with you are going to deal mostly with Shapely. Okay, when you deal with queries, spatial queries. Okay, the other day, I had a question. Say, okay, how long does it take to use Fiona to pass from X and Y set datasheet to a geospatial to a shape file? Okay, so and how will it take with your pandas? Okay, and how will it take? I mean, when we are talking about not 10 with 10 points, we are talking about 1 million points. Okay, and how it will take with another programming language? Okay, like C or like Rust. Okay, so this is a question that I want to work with. Okay, so Askanska, what is the question, Askanska? Okay, and there is a question from the the question of Riyadh is the whole code transform. I don't understand. What is the question, Riyadh? Yeah, okay, the out transform is an array, okay, and then we need this array in order to export the resulting map, the resulting array into a raster. We need that, okay, and this function gives you two results, okay, that is the image and the transform, okay, great. So we have the out image shape, okay, and the out image shape is this one. It has still 365 day. Okay, and then we can show a specific show out image then beaming is equal to 0. Okay, so this is Okay, great. So I say out empty. Okay, so now what we are going to do, okay, so for example, this is a presentation for a 1 day, okay, but we are going to, but if we see the out image, let's see the array, okay, because what you're looking here is an array, okay. Askanska, you want crop true is because there is a question here of why is crop true, I guess. Is because when you do the mask, you only clip to the part, but you have the call extension. But you crop it, you only have the resulting data frame will be just the extension of the of Colombia in this case. Okay, so we see here in the out image in the array, we have minus 1999. That is, this is a code for not data. Okay, so there is no data here because actually there is no data the precipitation on the at the sea. Okay, at least was not generated. Okay, so we are going to deal with that. So we first we do a copy. Otherwise, you risk of having circular reference. So out image 0. Okay, so we do a copy. So, and then we see, okay, whatever is in out, whatever has the name or the value of minus 1999, okay, whatever it has, this is called a np9. Okay, and okay, whatever has a value um, different from 1999 is a whatever is the value different from 1999 is a empty value, yeah, and whatever is because we select just the outside part. I'm not showing the notebook. Sorry. Yeah, I think that the other people are seeing something. Out empty is equal to 1 and plt im show out empty. Okay, great. So this is we have created something that has is empty for the it's empty for the land, okay, and it has a value of 1 for the outside. And why we do that? We do need that for the okay, we need that for the we need that. Okay, let me check if we need that. No, actually we don't need that in the later on, but this is how we can create a raster that has a value of 1 for the outside part and not a number for the inside part. Okay, let's see. But now we are going to do work with the values. Okay, so out image, where out image is equal to minus 1999. Okay, so this will be okay, this will be empty none. So because these are empty values, okay, great. So and then we are going to okay, then we are going to okay, so this is just the Luis Felipe, are you seeing my screen? I guess so. Ah, the previous line. Okay, I just send it as a row, but just because I want that you see the most of it. Okay, so let's see. Let's see. Okay, what we have done here is that for the empty values, it will be recognized as empty now. Okay, but let's see. Okay, so let's create, okay, an array, okay, of zero of empty nums, okay, that will store the days without rain. Okay, so let's say days no rain is equal to empty zeros, the out image shape one, okay. So because it will have, okay, out image has 365 shapes, so we are just taking, okay, the the rows and columns, okay, times num. Okay, so the days no rain will be this. Okay, so this is an empty array. Okay, this is an empty array. Okay, this is array that has the number of rows and columns, but where everything has a not a number. Well, everything has not a number. Okay, why? Because we are going to loop over each cell, and then we are going to store for the values that has values. It will store the days without the rain number. Okay, when is the case. Okay, if you are here with me, please type 1. Okay, so now let's see. N rows is equal to days no rain shape 0. N calls is equal to days no rain shape 1. For row in range of n rows, for call in range of n calls, okay, cell series is equal to out image. Okay, so we are going to do a slice here. Okay, we do a slice here where we from the out image, I mean from the 365 bands, we take all of these, we take all the 365 for that cell. Okay, so and then say it could be that all the 365 are not a number, so that is why we do an if cell series sum, okay, is higher or equal than 0. Why? Because if you are in the C, there is no data for the C. Okay, so all the data will be not a number. Okay, however, yeah, however, the sum of that, okay, will be also not a number because it's empty. Okay, so and by default our raster is empty, so actually we don't have to do nothing. For example, let's say, okay, so we have a point where there is no precipitation, okay, for all the year, for all the days, okay, but the sum of this is 0, okay, because there is 365 zeros. Okay, so if the sum is higher than 0, okay, we are going to store that value. So let's say days rain is equal to cell series. Okay, so but then we see the cell series higher than 0. Okay, because these are the days without rain, because no, this is the days of rain. Okay, the days of where is higher than, where the rain is higher than 0, okay, of shape 0. Mhm. Days no rain, roll call out image shape. Okay, so this is 365. Okay, in order to get the days of no rain is 365 minus the days of rain. Okay, and this is the magic. Okay, this is the core. This is the engine. This is all what. Okay, it has some pre-processing. It has some issues with the type, with the number type. It has some issues with the loop. Okay, yes, sure. Mm-hmm. Shape what? Yeah, because the there is no range shape is a tuple. So this is the row number and this is the column number. So if with this we slice to this item and the bracket one is this item because it starts from zero. You will be now counting all the okay. In the case if, for example, you have only 60 columns, okay, but you will be looping over 68, so you will have 8 columns that doesn't exist. Okay, Riyad? Okay, so now we can plot our final array, plt im show days no rain, plt dot color bar, and plt show. Okay, great. So this is in Colombia, and this is the Guajira, that is the place with less rain. Okay. Okay, as Kanka say, I'm following, but conceptually after importing the achievement. Yeah, I mean it's practice. I mean yeah, maybe if this is the first time that you deal with an array, with the shapefile, with the geometry, with the mask, that will be too much. Okay, but don't worry. I mean, only with training you will get more proficient in this. Okay. Okay, but I mean, it's a great step because you are doing all of this in Python while I don't know how to do this in a desktop software. I mean, I don't know. I mean, it's a process that for me to do it in a desktop software will be pretty much complicated. Okay, so let's explore. Okay, let's see our out transform. Okay, this is the array. Let's say there is no range type, so we are d type. So this is float of 64. Let's see of days no rain dot shape is 6080. Okay, so out raster is equal to rasterio dot open of data of days no rain thief. Okay, so there is no rain 2, comma. Okay. I will explain. Okay, I will explain something about what we have done. Okay, you have a NetCDF of the whole world. Okay, this is okay. And then you have a country. Okay, this is the country. Okay, and from that you clip all the data, and then you have just the raster, the 365, but just for your country. Okay, great. And then you create an array where everything is empty, okay, with everything is empty, okay, of this, of Okay, and for the values that has rain or do not have rain, you will have a value. For example, you will have empty here, but maybe you have 1, 2, 3 values. Okay, you count the days with rain. Okay, and then if you do the subtraction of 365 minus this, you will have the days of no rain. Okay, that is something related to the question, Askanska? Okay, great. So let's see. And now what you have is an array, but you need a raster because you need to, for example, to superpose that with another, with another, superpose with another data set or doing some other geoprocessing. Okay, so we are going to export this. Okay, and we are going to use Rasterio for do that. Okay, so it will be a geotiff. The width is equal to there is no rain shape one. So the height there is no rain shape 0. Count is equal to 1. The type is equal to days no rain. The type, okay, CRS is equal to rasterio CRS from EPSG 2026. Okay, and transform out transform. Okay, so we create an empty raster. I'm really sorry to be that this is so lengthy, but this is how it's needed. Okay, so when you deal with raster, there is nothing as GeoPandas because GeoPandas makes it so easy to create a shapefile, but when dealing with rasters, I mean Rasterio it makes it easy, but it still is pretty much you need a lot of uh, commands. Okay, arguments. Okay, great. If you are here with me, please type 3. If you are here with me, please type 3. Just to remember that we are from Hatari Labs, and Hatari Labs is a platform of knowledge sharing in water resources. And then we have a series of courses. Okay, we have a lot of diplomas. So if you want to take a diploma in Model Muse, if you want to take a diploma in FlowPy or in SWAT, you can take it, and this is the most complete, complete diplomas available in those software. Okay, we also have courses, and then we are also having webinars. Okay, just to remember that by signing up in our diploma courses, you are supporting our research. Okay, great. There is a question from Handumi. Say, can you provide the email for easy communication because I can be. Uh, well, if you okay, I'm going to drop my. Okay, this is my WhatsApp number for better communication because actually for me is to answer emails is also very late. Okay, yes, if for any general topic that I can provide some insight, I will do it. Okay. However, if you, I mean, if you want to pass me that I review the model of your master thesis, I'm sorry, I'm not going to do that. That has happened, no? Okay, so this creates the file, but you have to write things onto the file. So I say out raster write days no rain indexes is equal to 1 out raster dot close. Okay, great. Okay, with that, you okay? You with that, you you create the raster, you create the file, you write the data on the file, and it needs the index because even that there is only one band, okay, you need to specify that, and then you close it. Okay, great. If you are here with me, please type 4. Okay, and then, well, and finally, what you want is that, yeah, okay, and then if you want to days, okay, if we want to plot the geospatial raster, we say days raster is equal to rasterio. We open that, okay, okay, because we have closed the raster, okay, so we have to open just to show this is a data. There is no rain 2, okay, okay. Show this raster. Mhm. And this is the geospatial raster because what you're seeing here is long and lat. Okay, so this is a proof that you have done well your assignment. Okay, but we want what we want is to represent this with volume. Okay, and why we want to represent this with volume? Because we need to plot, because in volume you can also plot another shape files as well, and then you can do some pop-ups and other thing. Okay, so for that, what we are going to do is, okay, we are going to work a little bit with the array. So this array is equal to this raster read one. So we get a bound list. Bound list is equal to x for x in this raster bounds. Bound list. Okay, so this is the bound list. Okay, and then we have to do a tweak to represent the not a number. Okay, this array is equal to np num to num. Okay, this is okay. If you are learning Python, this is not the best top, not the most, but this is just to tweak where all the not a number will be expressed as 0. Okay, great. So in volume, in order to create a map, you need to have the lat and long of the area. Okay, so because actually it won't zoom to the area, so you have to specify the area and the zoom. Ras long is equal to bound list 3 plus bound list 1. Okay, so this is the centroid of the, this is the medium longitude, the medium latitude. Okay, great. If you are here with me, please type 5. Who else? Yeah, because this is the maximum longitude, this is the minimum longitude, this is the maximum latitude, this is the minimum latitude. Okay, great, 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 great. So now we create the volume map. So M is equal to volume map of location is equal to map center. Okay, that's why we need to specify. And the sum star we also need to specify, and this is it goes from 0 to 15, I guess. Okay, so in this case is 5 is okay. Image is equal to volume dot raster layers dot image overlay. Okay, this is one instance of volume. Okay, there are many other. Okay, so the image is equal to this array. The bounds is equal to bound list. Okay, so we have to put the minimum latitude, the minimum longitude, well, in this order. Okay, bound list 0. Opacity is equal to 0.6. Interactive is equal to true. Cross origin is equal to false. Okay, y aquí lo image to add. And then we add this to the map. Okay, this is how volume works. Um, and then we call the map. Okay, so we have added, but we haven't called the map. So we create a volume, a layer control as well to the map. and then M. Okay, voila, and then you have the representation. Okay, if you are here with me, please type 6. Okay, if you are here with me, please type 6. Why we divide by 2? Where we divide by 2? Yeah, because we don't need the range, we need the centroid of this. Mhm. Yeah. Mhm. Yeah, this is 38 rows of code. Yep. This is, yeah, what it takes to do the map and represent it. Okay, who else is here with me? Please type 6. So this will be the content of today's webinar.